So, students, let's have a review for the Math 9 quarter 2. Okay, so now without further ado, allow me to give you the first example or first situation. So in the first item, the perimeter of a regular hexagon varies directly as the length of its side. If the length of the side is 9 centimeter, and its perimeter would be 54, okay, 54 centimeter. What is its perimeter if the length of the side is 7 centimeter? Again, the keyword here is varies directly. So we are now in the problem of direct variation. So again, the perimeter varies directly as the side length. So we can represent it as P equals KS. It's up to you if you can use length or S, but in our example, we use S to represent the side length. Now, P for the perimeter, and K again, which is the constant, which has a vital role in this particular example. So, given the following, which is the P equals 54 and S equals 9. So, if the perimeter is 54 when S is equal to 9, we have to solve for the constant first. For us to solve the constant, we can divide the perimeter to to the side length, which is 9. So 54 divided by 9, then we can have 6. So our constant is equal to 6. And we can use the constant to basically change the k here. So we can have our new formula, p which is p, like right here, p equals 6 times s. Okay, 6 is our constant. So now when s is equal to 7, we can change the s here, or the side length. So 6, it will become 6 times 7. Then the perimeter would be equal to 42. So the perimeter is equal to 42 centimeter. The answer is letter A. Now, in the item number 2, y varies inversely as x and y equals 3 when x is equal to 6. Which among the following best describes the equation of variation? In this case, we talk about the inverse variation. So we have here the y varies inversely as x, which is the main thing. We can represent it as y equals k over x. Now we have the first given. The first y is 3 and x would be 6. We have to find the k. So for us to find the k, we can use uh, the k in the inverse variation. We can just multiply the x and y. Okay. In this case, we have the k here, and then we substitute the 3, which is our y, and then in 6 we have the x. Okay, and then for us to solve for the k, we can multiply 6 by 3. So 6 times 3, that is equal to 18. Okay, again, for us to find the k value, so just multiply the x and y, or to find the constant. So when we find the constant of this given, then we can create another formula or new formula. Y equals 18 over, I think we can have this equation. The equation would be y equals 18 over x. So the final answer would be letter D, because we just described the equation of this variation. Letter D. Now number 3 would be the area of the rectangle varies jointly as its length and width. How is its area changed if the length is doubled and its width doubled? So here we talk about the joint variation. And then this main idea, area of the rectangle varies jointly as the length and width, can be represented as A, which represent the area. Uh, L is length, width would be W. So if both length and width are doubled, what will happen? So the A prime or area would be K times 2L because we want to make it doubled times 2W. So here we multiply the coefficient here, 2 times 2, that is 4. And then we copy the K, L, and W here. Okay? So as you can see, our area just quadrupled. Okay? And the answer here in this given would be letter D, quadrupled. So we have 4 here, right? So number 4, the volume of the right circular cone varies jointly as its height and the square of its radius. Which among the following best describes this? First, the volume we all know is equal to since varies jointly is equal to K times the square of the radius times H. Okay? So again, because it varies jointly as height and the square of radius, which represents this one, okay, the answer would be a letter B. Okay, so now let's proceed to number 5. Z varies directly as x and inversely as square of y. And z equals 6 when y equals 2 and x equals 3. Find the value of z when x equals 3 and y equals 4. So, again, how can we represent it? Z varies directly as x. So, x, we can write it in our numerator. And the y squared or the square of y would be written here in the denominator. So, maybe you can write the k here beside the x, or you can write k here. So, it's up to you. Now, we solve for k given the first value of z, x, and y. Z is 6, x is 3, y is 2. So, again, we substitute the z, the x, and the y. And then we can simplify it. So, we can simplify 2 squared, which is 4. And then we have k times 3 over 4. So, now, given the 6 equals, for example, we can have 3k here over 4. You can use this alternative option, 6 times 4, that is equal to 24 equals 3k. And we divide both sides by 3, and then k would be 8. So just like we did here. Okay? Again, the constant of variation would be 8. Now we have x equals 3 and y equals 4. So that is the given. So we have to find the value of z. For us to find the value of z, we just simplify them. Plug in the x, which is here. And then plug in the y, which is here. And then the constant would be 8. Okay? Then we simplify them. So we have 8 times 3 over 16, because 4 squared is 16. And then we multiply them. And then simplify it, get the lowest term. You can use your calculator if you want to. So 3 over 2 would be the simplest form, or the lowest term. Or if you can write it in the decimal form, 1.5. So the final answer here would be letter B, 3 over 2. Number 6, the weight of a cylindrical metal bar varies jointly as its length and the square of its diameter. If the weight of the bar is 63 kilogram, when the length is 63 centimeter and the diameter is 3 centimeter, find the length of the bar when the weight is 20 kilogram and of diameter of 2 centimeters. So what can we do here? We have to recognize that this is the main theme of this particular item. So we can write it as weight. Weight is W, represents to W. Again, length would be L. Square of the diameter is D squared. So first, we must recognize that there must be a given or first W, length and diameter here. So W or weight would be 63, length is 63, diameter would be 3. So first we have to simplify the K or the constant by substituting or plugging in the W, the length, and the the given value of the diameter. So, simplifying them, so 63, just bring it down, and k, bring it down. 3 squared would be 9. And then 63, you can write it here, of course, the 63 as well. And then dividing both sides by 567 for us to find the k. So 63 over 567 can be lowest term into 1 over 9. So our k here is 1 over 9. As we move on, as we move forward, we have the new value of weight, which is 20. The diameter would be 2. And we asked to find the length of this bar. So how can we find the length? Of course, we substitute or plug in. For example, this is our new formula. We have W equals 1 over 9 times length times diameter squared. So we just plug in the weight here, and then the weight and diameter here. So we have this kind of equation. So 20 equals 1 over 9 times length times 2 squared. We can simplify 2 squared first. So we have 4L. Okay, so we can write here the 4 in the numerator beside the L, or the length, over 9 equals 20. And then we multiply them. So 20 times 9, giving us 180, I suppose. So 180 divided by 4 will give us, I think that would be 45 centimeter. Okay, and that is the final answer. Now, letter B would be our answer here. Number 7 is, if y varies inversely as x and y equals 6, when x is equal to 4, what is y when x is equal to 6? Again, this is the main theme. Y varies inversely as x, and we can represent it as y equals k over x. So given the first x and y, 6 is y, x is 4, we can plug in our equation. Again, to find the constant in inverse variation, we have to multiply the x and y. So 6, which is the y, 4 would be the x. And that is resulting to 24. And that is our k. Now, when x is equal to 6, then substituting in our new equation, y equals 24 over x, okay? Just plug in the x here. So we have here in the denominator, we have x, that is 6, and then dividing them, simplifying 24 divided by 6, that is equal to 4. And the answer would be 4. The volume V of a rectangular prism varies jointly as its length L, with W, and height H. If V equals 480, when the length is 8, W is 5, and height is 3, find the volume, or V, when L is 10, W is 4, and height is 5. So what can we do here? We have to recognize that this is the representation of this particular given. Varies jointly once again, so this is the formula, or this is the format. V equals K times length times width times height. So in this case, we use the first value. We have the volume equals 480 here, and then length is 8, W is 5, H is 3. Then we plug in all the values that we have. So the volume would be 480, the length would be 8, the width 5, the height 3, as stipulated here. So we simplify them. 8 times 3 times 5 times 3, that would be 120, and then 480 divided by 120, giving us the value of k. And the value of k here would be 4. Now, we have the new formula. V equals 4 times length times width times height. And then we plug in the new given, the second given, which is the length is 10, width is 4, H is 5. And then plugging them, we have the 4 times 10, which is the length. Width is 4, height is 5. Then multiplying them together, giving us 4 times 10 times 4 times 5 is 200. 4 times 200, that would be 800. And that is the final answer, 800. Number 9, if y varies jointly as x and the square of z and y equals 200 when x equals 4 and and uh, and 5 and 5 or z equals 5, find y when x equals 5 and z equals 4. So in this case, varies jointly once again, and then this is the representation y equals k times x, which is here, times the square of z, which is z squared. Again, the first value of y equals 200 when x equals to 4, z equals to 5. We change the value of y, x, z. So we have this one, and then simplify the 5 squared, which is 25, times 4 times k. I think we have 200 here. And then 4 times 25 is 100k. So we have 200 here. And then dividing both sides by 100k will give us 200 divided by 100. That is k equals 2. That is the first, that is the constant of this variation. So the new formula would be y equals 2 times x times z squared. Now we have x equals 5 and then z equals 4. So plugging them, the second value, 5 would be the x, z would be the 4, and then simplifying them, 4 squared is 16 times 2 times 5, that is equal to 160. So the answer would be letter B. If y varies directly as x and inversely as z, and y equals 20 when x equals 8 and z equals 4, find y when x equals 9 and z equals 6. So the first thing that we need to do is to represent it directly and inversely. Directly to x and then inversely to z. So that is the representation. And then plugging the value of y, x, and z will give us 20, which is the y, and then k, the thing that we need to look on, x would be 8, and then 4 would be z. So as we simplify 8 divided by 4, we have 2k. Dividing both sides by 2 will give us k equals 10. And then when we have this new formation, y equals 10 times x over z. Then we plug in the x and z. Okay, so the x here would be 9, the z would be 6. So 10 times 9 divided by 6 will give us 15. And then the answer would be letter A, 15. Which of the following is the simplest form of a square root of 50? Again, so we have to simplify square root of 50. To simplify that, we have to find the factors of 50 that has a perfect square number. So we have 25 times 2. Then we get a square root of 25 and then square root of 2. Square root of 25, that is equal to 5 square root of 2. And the answer would be letter B, 5 square root of 2. Number 12, simplify cube root of x raised to 7, y raised to 8, z equal raised to 9. Which of the following represents its simplest form? Okay, so again, we simplify this one. We break into cubes. So we have cube root of these things. So x raised to 6 times x can be written as the different form of x raised to 7 is this one. Also, we have y raised to 6 times 2 is the other way to write y raised to 8. Again, when we are multiplying with the same basis, we add the two exponents. 6 plus 2 is 8. 6 plus 1 is 7. And then z equals 9. Z raised to 9. Okay? So, yan. Then, we simplify the following. So, we have x raised to 6. I think 6, we can divide it by 3. The answer is x raised to 2. Okay? So, we will write it outside the radical sign. And then the remaining x raised to 1 will remain inside the radical sign. Also, we have y raised to 6, y raised to 6 divided by 3, the 6th exponent divided by 3, that is y raised to 2. And there must be a remaining one, the y squared. Since we don't have whole number when we divide it to 3, it will remain to the y, to the inside of the radical sign. Also, we have z raised to 9. 9 divided by 3, that is z raised to 3. As you notice, we don't have z left here because all of the numbers is get the whole number when we divide it. This exponent 9 to 3. And I think the final answer would be letter A. X raised to 2, y raised to 2, z raised to 3, cube root of x, y squared. Now, if the simplest form of the radical expression is square root of 108 is in the form of x square root of y, which of the following is the value of x raised to y? Next thing that we need to do is to get the simplest form of 108. So when we get the factor of 108, which has a perfect square number, that is 36 times 3. So simplifying this, square root of 36 is 6. Square root of 3 would remain. So as we notice, we have here the x, okay? This one is our x, and the 3 would be our y. As the format here in x, square root of y. And when we use this x raised to y, so again, our x is 6, our y is 3. From here, we can simplify, substitute the x and y here. X would be 6, y would be 3. So simplifying 6 raised to 3, which give us 216. So the answer would be letter A. 14. Simplify the expression 190 square root of 196, g raised to 5, 9, r to the 9th power, a to the 11th, d to the 13th, and e to the 15th. So, in this case, we simplify the expression. The first thing that we need to do is to write here. Okay, we break the radical into separate parts. Of course, the square root of 196 we have here. Square root of g raised to 5, square root of r raised to 9, square root of a raised to 11, square root of d raised to 13, square root of e raised to 15. So, we simplify each square root. So, 196 or square root of 196 is 1 or 14. Square root of g raised to 5 we can write g squared square root of g because 5 equals 2 times 2 plus 1. There must be a remainder. So there is 1 here. Okay? Just like we did earlier. So square root of 9, r raised to 9, since 2, 9 divided by 2 is 4. So we have right here 4. And there must be remainder 1. And then square root of 11 or a raised to 11, 11 divided by 2, that is 5. And then there must be a remainder 1. Square root of d raised to 13. 13 divided by 2 is 6. There must be a remainder 1. And the square root of e raised to 15. 15 divided by 2, that is 7. There must be a remainder 1. So, when we combine all the whole parts into radicals, so the answer would be this one. So the simplified form or version is this, and the final answer would be letter C. Okay, 14g squared, r to the 4th, a to the 5th, d to the 6th, e to the 7th, square root of grade. Okay, so that's it. Number 15, derive the rule for multiplying radicals square root of a times square root of b. I think we can write or derive it as using this rule. Write the radicals as fractional exponents like square root of a times square root of b. We can write it as a raised to 1 over 2, b raised to 1 over 2 because that is a fractional exponents. And then we write the bases here inside the parentheses, and we can raise it to the one common exponent, 1/2. And then when we write here the AB raised to 1/2, we can write square root of AB. That's the other form. And the answer would be square root of AB. So which of the following is a true statement? Okay, so we check letter C, square root of 7 times square root of 5. It can be written as square root of 7 times 5, and the answer would be square root of 35. Our choices or the other choices are false, therefore the answer would be letter C. Which of the following is a simplified result of square root of 18 times square root of 2? Again, square root of 18 times square root of 2 can be written as square root of 36. We just multiply 18 and 2 to have 36. Square root of 36 is 6. The answer would be letter A, 6. Simplify cube root of 64 times cube root of 8. So I can simplify that. So cube root of 64, this one can be written as cube root of 64 times 8. So 64 times 8 would be 512. And the cube root of 512 is 8. Since 8 cube is equal to 512. Or if you can write it in your calculator, the answer would be 8. So the answer would be letter C. Number 19, analyze the expression 5 square root of 5 plus 26 square root of 5 minus 27 square root of 5. Which of the following represents the correct simplified form of the expression? So we simplify this one, and then we combine like terms. So combining like terms, I think we have the common inside number, radicand. So combining them, 5 plus 26 minus 27, which give us a 4. Okay, when we simplify this one, square root of 5. And the answer would be A, 4 square root of 5. So which of the following is the value of 6 square root of 3 minus 8 square root of 12? So again, finding this one would give us square root of 12. I think we can simplify this one and find the factors of 12, which has a perfect square number. In this case, 4 times 3. Square root of 4 would give us 2. Okay, square root of 4 would be 2. Square root of 3 is this one. Will remain inside the radicand. Now, we have 8 square root of 12 can be written as 8 times 2 square root of 3. So what does it mean? We can multiply 8 times 2 here. So that is equal to 16 square root of 3. So therefore, 6 square root of 3, we just copy here, minus 16 square root of 3, the result of solving this one and this one, we have 16 square root of 3. And then since they have the same radicals and then radicand, we can simplify them. 6 minus 10 or 16, that is equal to negative 10 square root of 3. The answer would be letter C. 21. Give the product of 2 square root of 2 plus 3 times 4 square root of 2 minus 5. Again, we can use the FOIL method here. So the FOIL method, and when we're multiplying binomials, would be the first term would be 2 square root of 2 times 4 square root of 2. As to simplify it, 2 times 4, that is 8, and the square root of 2 times square root of 2. I think we can just cancel this one because they have the same value. So 8 times 2 would be the remaining. Or go ahead, you can multiply them. 2 times 2 is 4, square root of 4, that is 2. And then the answer would be 16. 8 times 2 is 16. Then we now move on to the outer part. So we have 2 square root of 2 times times negative 5. So in this case, we just multiply negative 5 and 2. And then we have negative 10 square root of 2. Okay. Next, inner side. 3 times 4 square root of 2. So does it mean 4 times 3 or 3 times 4? That is equal to 12 square root of 2. And then last term would be 3 times negative 5? The answer would be negative 15. Okay? So the next thing, we combine all the results, and then we combine the similar terms. Negative 16 minus 15, the first and the last, because they don't have any letters or any radicals. And then we have negative 10 square root of 2 plus 12 square root of 2, the outer and the inner, because they have the same radicals and radicand. So 16 minus 15 is 1. Okay? And then negative 10 plus 2 is equal to positive 2. So the answer would be 2 square root of 2 plus 1. So okay, just rearrange this one and then we can write it as this final answer. 22. Find the quotient of square root of 3 over 4 minus square root of 5. Again, we can have this quotient and rationalize the denominator. I think we can conjugate them. Multiply it by this conjugate, 4 plus square root of 5. Ayan. And then we have this one, square root of 3 times 4 square root of 5. We can write it here in the numerator. In the denominator, we perform the FOIL method as well. So, distributing them in the numerator, for square root of 3 times 4, we have 4 square root of 3. Square root of 3 times 5, we have square root of 15. And then here, we just cancel this one. And then multiply 4 times 4, that is 16. And then 5 times square root of 5 and square root of 5 would give us 5 only. And then I think there must be a cancellation there. And the remaining would be 16 minus 5, because negative times positive is negative. There must be a rule or property here that we can follow. And then we simplify the numerator. There's nothing to do with the numerator. Denominator, yes. 16 minus 5, we have 11. The final answer would be letter C, 4 square root of 3 plus square root of 15 over 11. Which of the following is the first step in solving equation involving radicals? I think the answer would be you should isolate the radicals on the one side before raising both sides to the power. So letter C would be the final answer. Isolate the radicals on the one side. 24. Which of the following is the value of x in square root of 3x equals 9? So the next thing that we need to do is to square both sides. So when we square both sides, we have this one, and then we can cancel the square. The remaining would be 3x equals square of 9, that is 81. And then divide both sides by 3. Okay? And then when we divide both sides by 3, the 81 divided by 3, that is 27. So the answer would be letter B. Find the value of 4 square root of x plus 2 equals 16. Again, here we have this particular given. We can divide both sides by 4. Divide both sides by 4. Okay, we can eliminate that. The remaining would be square root of x plus 2 equals 16 divided by 4. The answer is 4. And then square both sides of the equation. This one will cancel up, and the remaining would be x plus 2 equals 4 squared. That is equal to 16. And then isolating the x would give us x equals 14, because 2 will, we can subtract 2 both sides, and then 16 minus 2 equals 14. And then the answer would be letter D, 14. 26. If x square root of x plus 1 equals 3, then x plus 2, 1 squared is equal to. So here we have the square root of x plus 1 equals 3. We just find x plus 1 squared. From square root of x plus 1 equals 3, we get x plus 1 equals 9. Why? Because we want to eliminate this square root, we have to square both sides. And then canceling this one, x plus 1 would be the remaining. 3 squared is 9. Solving for x, we just get the squared of this particular given, x plus 1 squared, will give us, in the other side of the equation, will give us 9 squared as well. Okay, because we are looking for the x plus 1 value. So what is the x plus 1 value? The result of 9 squared. The 9 squared would be 81. Therefore, the final answer would be 81. Letter C. 27. Find the area of the square whose side is square root of 3 plus 2 centimeter. Again, the area of the square with side s is equal to square root of 3 plus 2. And then the area, we all know that s squared. And then square root of 3 plus 2, quantity squared. Again, the side is this one. We can substitute it in the s value. Applying the property, the square the first term, that is square root of 3 squared. Okay? And then multiply the two terms times 2. We have 2 times 2 square root of 3. Okay? And then square of the last term, which is 2 squared. I think we can cancel this up. We can multiply this 2 times 2 and then simplify this one. So we have square root of 3 squared, 3 remaining. 2 times 2 is 4. Square root of 3, just copy. Then 2 squared, we have 4. And combining both sides, 3 and 4 will give us 7. And then copy 4 square root of 3. So the final answer is letter C, 7 plus 4 square root of 3. Okay, so the square root of the sum of the two consecutive integers is 5 square root of 3. Find the larger integer. So the square root of sum of the two consecutive integers is 5 square root of 3. Find the larger integer. Let integer be n, and n plus 1 would be the next integer. Then, square root of n plus 1 would be the given here, equals the square root of 2n plus 1. Again, there must be a given here, square root of the sum of the two consecutive integers, which is here. Okay? So the next thing that we need to do is to, again, simplify it. N plus n will give us 2n plus 1, just copy. And then we have the 5 square root of 3. So how did you get it? Because the consecutive integer is equal to 5 square root of 3. I think we can write it as this format. So 2n plus 1 equals 5 square root of 3. So we can get a square root of the both sides, cancel up. So we have 2n plus 1 equals 5 squared. That is, I think 25. This one is 25. And then square root of 3, square root of 3 squared, we can cancel them. The remaining would be 3. Then simplifying them, we have 25 times 3, that is 75. And then 2n plus 1. We can substitute or transpose 1 to the other side. We have 2n equals 74. Dividing both sides by 2 will give us n equals, I think this one is, the final answer would be 37. Okay, that is our n. Okay, however, that is the first integer. The larger integer would be, we have to add 1. So n plus 1 is equal to, again, our n is 37. That is equal to 37 plus 1. That is equal to 38. The larger integer is 38. Okay? The larger integer is 38. Next, find the measure of the side of the square if its diagonal is square root of 8. So here, we have the diagonal d equals s square root of 2. So, s is equal to d over square root of 2. In this case, we have the square root of 8, which is the value of the diagonal, okay, over square root of 2. I think we can write it as 8 over 2 if we've applied the quotient property. And then 8 divided by 2 is 4. So square root of 4 will give us 2 centimeters. So the answer would be letter A. And finally, the square root of the sum of the two consecutive odd integers is 8. Find the two integers. Okay, so let consecutive odd integers be 2k. plus 1 and 2k plus 3. Okay, the sum would be 2k plus 1 plus 2k plus 3. And then we can write it as 4k plus 4. Why? Because 2k plus 2k is 4k. 1 plus 3 is 4. And then again, we can say that the square root, the sum. So we have to write the square root here. 4k plus 4 equals 8. Why? Because the square of the sum is equal to 8. And then we get the square root or the square of the both sides to finally cancel this one. So we have 4k plus 4. 8 squared is 64. And then we subtract both sides by 4. Will give us 4k equals 64 minus 4, that is 60. Dividing both sides by 4 will give us k equals 15. And the next one is the integers of 2, substituting it to the k. The k is 15. 2 times 15 plus 1. Okay? 30 plus 1 is 31. So that's the first number. Okay? I think we have this one. But let's verify if that is 33, the next integer. The next integer is 2 plus 15 plus 3. Okay? So this one, we plug in the k that we gather here. 2 times 15, that is 30 plus 3, that is 33. So the answer would be letter A. And that's it. That's how we review this particular quarter 2 reviewer. So I hope you practice the following items. You can go back if you want to. Again, as you can practice the skill 1% at a time. No, 1% is just equal to 14 minutes of your whole day. Okay, so we believe in practice. Practice makes progress. Okay, the result of your performance will depend on your effort. Okay, because your effort is directly proportional or varies directly to your grades or to the outcome of your grades. Okay, so the more effort that you have, the more or the better grades that you may uh, may get. But on the contrast, the less effort, the less grade. Anyways, good luck to your examination in the Mathematics Quarter 2, Mathematics 9. See you in our class.